Welcome to this session about SQL Server Data Tools. My name is Gert Drapers. I'm the Group Program Manager for the Data Platform team. So what we're going to do today is we're going to talk about why we build SQL Server Data Tools, what it is, and how it works. So we all know that SQL Server data development or database development is actually very hard. Databases are stateful entities, so making a change has consequences. And these consequences are actually exaggerated by the fact that we have to deal with dependencies between objects, and we need to preserve the state because we don't want to lose any data. The T-SQL language as well is a challenging language because a lot of errors hide out till we actually execute the code. And if we add on top of that the applications that consume the databases, we're actually adding more layers of complexity. Now, if you then start to add the last complexity in terms of what if I want to take this database and move it from an on-premise into the cloud? We're actually completing the story on why database development is hard. So are we at a loss, or is there a better way? Well, we actually believe that there are better ways of doing this. We could start to develop our databases in a declarative fashion. By that we mean that it's like you express what you want and not how do you want to get there. This also adds another benefit, where it's like we're adding the validation of errors and runtime problems into a design time environment instead of a runtime environment. So what we're doing is we're exposing the errors that your application might run into to the developer in a way that he can respond on it and act on it. So how do we set this up? Well, first of all, we want to build up an isolated environment that the developer can use so he can make changes and test changes in a sandboxed environment where he doesn't bother other people. And only when he's ready, he will publish out those changes. So let's dive into what SQL Server Data Tools really are. So it's a development tool set that starts with a database project. And we use this project as a container for all our sources that we need to manage. And we have some rich tool support inside the database project to help the developer do his daily job in the form of rich editing environments, debugger experiences, and integration into this local runtime database that creates this isolated environment that the developer can work in. So, in a nutshell, SQL Server Data Tools is based on a couple of foundations. First of all, it promotes a declarative way of working. This means that we're deriving everything from a model. We integrate this into a rich tooling environment that allows you to work both on a connected way as well as disconnected. And it allows you to target not only SQL Server that you have on-premise, but also SQL Azure. And it knows when the information or the databases underneath you changes. Because you're never alone inside a database environment and make changes on your own. So let's look at our first way of how we can actually use SQL Server Data Tools in a connected fashion. Okay, so our first part of SQL Server Data Tools that we're going to look at is how we're going to use it in a connected fashion. So I launched the tool, and what you see here is the Visual Studio shell with SQL Server Data Tools and the new SQL Server Object Explorer loaded. I can use this tool window just like the SSMS Object Explorer to navigate my databases and my objects. So what we see here is that the database that I'm going to use for this demo called Dinner Now. And I am going to launch an editor in there just like you would do in SSMS that you can use to execute your queries and look at your results. Since I got this database from a developer, the first thing that I want to do is check if there are actually any missing indexes. And so what I'm going to do is I'm going to create a query window, and I'm going to take my script to search for any missing indexes. Execute the query just like you would, and you would get the results in your familiar grid window. You would get your messages and all the other results just like you're expected. So we see that we have a couple of indexes missing that the developer forgot to actually add to his project. So let's see what we can do about this. So the first way that we can do this is we walk up to the table and we simply double click, which will load the table designer. This will give us a view both in a dialog mode and a code mode. And we instantly see that it's like we have a foreign key, but we are missing an index. So what we do is we can simply right click on the index, say that we want to add a new index. We're going to give this the name of the column just to cohere to the style that we have been using. We'll call it restaurant ID. I want to use that later, so okay. So what that will do is actually it will add a bunch of code at the end of our script to create the index. So you see a red squiggle instantly showing up, which means it's like that we're referring to a column that doesn't exist, which is true because we want to name this the restaurant ID. Right now it's like we change the name and the red squiggle goes away. Now while we're making these changes, the changes effectively haven't happened yet. So if I go into this mode, I simply see it's like that there are no indexes yet. So what I'm doing here is I'm actually making the changes in memory on my client. We call that buffered mode. And we're going to batch all these changes up until we say that we actually want to go and execute or update the target database. So we saw in our script that we have a bunch more that we need to go update. And I don't want to do that through the table designer one by one. And so what I'm going to do is I'm actually going to do that through a code window. So we're going to open up a code window, and I'll take this out for a moment. And I'm going to add all the indexes that I want to create. So here we have the script as you would normally do this. And so what we have now is that we have a set of outstanding changes against this database. We added an index over here. And we created some indexes on this, in this editor over here. And on both sides, you see that we have an update window. And since they're both pointing to the same database, if I choose this update window, it will bring up the preview, and it will consolidate all the changes that we've made. And so it tells us that it's going to create all the indexes from both windows, both on the menu. Here you see the first one. And then the ones that we have on the other databases or other tables as well. I can choose two options. I can generate the script that results in performing those actions in case you want to see what happens, or I can immediately go ahead and update the target database. So I'll hit Update Database, and what that does, it's like it brings up the Tools Operation window, which will show us that we are preparing the changes. It allows us to preview the changes. So this was the script that we actually used to deploy those changes. And then when we're done, it's like it shows us the result and everything happens successfully. And so the key thing is here that if you have long-running operations, like for example, updating an existing index could be taking a little while, it will not block your environment and you can just continue to work in your IDE, make other changes, consolidate them, and move on to the next step. So that's the first part that I wanted to show you, how SSDT actually takes a different approach of managing your schema. And now we'll get ready for the next step. Now that we saw how we can use SQL Server Data Tools in a connected fashion, so we've seen the SQL Server Object Explorer, which just works and looks like the SSMS Object Explorer. And that's for a reason. So you can retain your memory muscle and do the things that you're used to. You saw how we expose a rich editing environment and debugging environment, including IntelliSense, and how we can buffer up changes and consolidate those and push those out in a declarative fashion. So that creates a very rich environment for you to manage your database schemas and your databases in an online fashion. But if you want to do more complicated things or want to work inside a team environment, you really want to work in an offline fashion. So let's look at how we can use SQL Server Data Tools to build up this disconnected offline representation. Okay, so we've seen how we can actually use SQL Server Data Tools in an online fashion. Let's move on to the next topic, which is how we can leverage SSDT in an offline fashion. This will allow us to version the database and make changes completely independent of our live database. So how do we do this? Well, we start by creating a project. The first thing we do is walk over to our database, dinner now, and say create new project. We'll give the project a name. This can be any name that you would like. We'll call it just dinner now, same as the database, and we'll hit start. What this will do is it will reverse engineer everything that we have inside our database into a source code representation. So what that means is that we now have, if we move over to the Solution Explorer, a project with a set of files representing the objects we have inside our database. So here you see the files that correspond with the tables that we have on the left-hand side. So let's go to the same table that we were editing earlier, the menu table. Let's open it up, and what you will see is you will see exactly the same designer representation, right? Code behind for our source code and our dialog-based editor in the top, but now representing the information that is actually coming from our source code file. So instead of from a database, we're rendering the same information. Now the key difference, of course, is that since this is source code, we can say view code, right? And we can actually go and make changes in this file in source code without disturbing anybody else. So we're going to leverage that technique to actually make a bigger change inside our system. We're going to introduce a enum system that we're using as a standard inside our company that was already created by somebody else. So we're going to bring that into our world by importing an existing SQL script. And we're simply going to point to the file that has this information, which is called enums. It's a SQL script file. We're going to open it up, walk through it, and import the information into our system. And what that does, it brings in a file called enums.sql, which has a table name definition. And it brings in some other objects, like some stored procedure called setEnum, and some functions that we can use to validate if this is a valid enum or not. So the next step that we're going to do is leverage this system inside our orders table. So we'll move to the orders table. So we'll scoot over the Object Explorer to the side, and we're going to make our change. So we'll move over to orders, and we're going to add a column which we call status. We want to track the order status, and we're going to do that through a field of type integer. It's not going to be null, and we're going to say it has a default value of 0. Now, of course, that is like we have now an integer representation. We would like to get the string representation as well. So in order to do that, what we're going to do is add a string representation in the form of a computed column, and we'll simply drag that in, and here we have our computed column. And you see us adding this into the code window. So now we have our integer variation. We have a string representation, which is a computed column. The only thing we now need to do is make sure that the information that is being entered is actually valid. And we're going to do this by adding a constraint. So we're going to add a constraint to the system as well. Here we have our constraint. Oops. Go back. And so indented, and we see a red squiggle, so we have to pay attention. And so that is over here because we missed the comma. So now we're in a state that that's where we wanted to be. We updated our orders table. So let's save this, and what happens, it just updates the file. So nothing happened in our target database. And while we're working on this, the first thing that we want to do is validate that this actually works. And we do this by building the project. So we go and build, and we say, hey, no errors, that is good news. So let's deploy this. So we hit F5, and that will bring our information, our project, and deploy it to our local database. So if I go back to Object Explorer, here I see that I created a local DB instance. I have a dinner now instance. I have my tables, I have my views, and I have my programmability objects like my stored procedure. So I can now take this stored procedure and actually start to debug it. So here we see our stored procedure, and now we want to validate that it actually works. So the way to do this is by using the debugger. I open the source code representation. I already set my breakpoint, and you see here the input parameters that we're going to use. So by simply saying, take this stored procedure and debug it, it will ask me for the input variables. So This is the name that we're going to use of the group of the enum. And there's going to be an item, and then it will have a value. So let's say it's value number 2. Okay. This will create me a script that I can use over and over and can start debugging it. So I'm going to step in. This brings me into the source code of my stored procedure. It tests if it exists. It doesn't exist right now, so it's going to insert. And I can replay this same script again and debug it again by hitting execute with debugger, step in, and we now see that we take the other code paths. So our stored procedure actually works as advertised. Great. So that allows us to use our local test environment to validate if we're actually fine. So the next step will be to actually start deploying this. And that's where the next demo will start.
Great.
Now that we've built up our project, you've seen that we manage the database definitions as source code fragments inside our project. So this allows us to enable even richer environment for the developer, like finding all the references or where is all this code being used. It allows us to refactor our code and enable the local environment for validation using F5 debugging. So we also enable this like a local sandbox environment that allows the developer through F5 to validate its code. And we can visualize the differences between the different environments using a comparison tool that allows you to synchronize the changes between your projects and your databases in a very easy way. So let's look now that we've finished our project, of how we can take our project and deploy this to a SQL Azure database. Okay, so up to the next and last part. We have our project representation of our database, and we now want to start publishing this to SQL Azure. So how do we go about that? So first of all, what we're going to say is we're going to tell our project that it's going to target SQL Azure. So we're going into our project properties, and we're going to switch the property to be it pointing to SQL Azure. So after that, we're going back and say build our solution, and we'll actually, we'll see that there is one failure. Well, this is actually totally expected because we know that SQL Azure doesn't support non-clustered indexes, or it's like it always requires a clustered index, I should say. That's better. So it points out where the error is. We'll simply fix up the error. We'll save the source code file. We'll build it again. And hopefully now we're fine. And so it says. So what do we do next? We go and publish our database. So we go into our publish dialog. We'll point the connection to SQL Azure. And the way that we're actually going to do this is by loading a profile. What this profile does is actually, I'll show you here, it remembered my Azure connection string, and it remembers my password. It points it to the database called dinner now, and we're going to hit publish. And so what this will do is it will bring up again the tools operations window. It will start to publish the master script and the database script, and then it will you see here that it's actually creating all those objects that are in there, and it keeps on going, and it says it was successful. So one quick check, we go to our Object Explorer, we hook it up to Azure, and we're going to find if there are actually any databases out there. So let's refresh. And if we are happy, it's like we should see that there actually is a database now called dinner now. Yep, there it is. And so here we see that it's like we actually have our objects, and we're all ready to go. So there it is. So that concludes our demo. We've shown you how to actually get your database represented inside a project system, how to manipulate it to a declarative way, and how to migrate your existing database to Azure. So you've seen that we successfully deployed our database to SQL Azure. But it's worthwhile to note that actually you can use SQL Server Data Tools regardless of your version. So we support SQL Server 2005, the 2008 versions, 2012, and SQL Azure side by side. So you only really need one tool to target those different versions in SQL Server. And we have a variety of ways of how we can actually deploy it to those databases, either directly over a TDS connection, creating a T-SQL script for you, or by producing a deck pack that you can then upload to the Azure portal, for example. One feature that we didn't touch on, but it is very interesting to point out, is the notion of snapshots. This allows you to persist a point of time, or point in time, of your schema as you're working. So this allows you to actually make little snapshots and start to compare them while you're moving on. So in summary, SQL Server Data Tools is the standard database development environment that we are now delivering with SQL Server 2012. It's hosted in a familiar Visual Studio environment, right, and it supports all these versions of SQL Server that I listed before. We will actually update this tool set at the same cadence as SQL Azure. That means we're going to deliver this to you both in an online and offline fashion, so you can stay up to date. And the most interesting part is, it actually is available for free. So if you want to find out more, it's like I encourage you to visit our blog or post the questions on the MSDN forum. You can also download the latest version of SSDT at any given time through the link that you see here. And we have some videos from the last TechEd that go into some more details. And then, of course, it's like for some further information, I encourage you to actually visit the Virtual Academy and download SQL Server 2012 Trial Edition to play some more with all the good stuff that we delivered. Thank you.